The third part, the function and introduction of each icon. Here, enter the sheet thickness of the processing material. Here, enter the sheet length of the processing material. Here you select up punch. Here you select lower die. Here you choose blocking. Enter the angle required for processing products here. Enter the size of x-axis here. Here is the size of the r-axis. Sometimes we may encounter this situation because the angle gear finger cannot touch the workpiece well. At this time, you need to adjust the gear finger position higher. In this way, the workpiece can be successfully resisted. Similarly, sometimes there may be situations where the gear fingers are too high to withstand the workpiece. At this time, you need to lower the gear finger. This way, it can smoothly resist the workpiece. This is opening height. The opening height is the height of the slider's rebound after one processing. Now it is 130 millimeters. Let's check it. Now we change it to 20 millimeters. We can make suitable changes according to the size of the product. This is speed changing point. The entire bending process is divided into fast downward, slow downward, pressure holding or mute mode, and return mode. The meaning of the speed change point is the distance between the upper punch and the lower die, which changes from fast downward to slow downward during bending. It is 10 millimeters now. Change it to 30 millimeters and show again. Now it starts to slow down from the 30 millimeters position. We make it even higher for 50 millimeters and show. Now it starts to slow down from the 50 millimeters position. This is the pressure holding time. There will be a pause after the fast and the slow downward are completed, which is 0.2 seconds now. Now we change it to 2 seconds and show. This is slow downward speed, which is 10 millimeters per second for now. We change it to 5 millimeters per second and show. This is the compensation. When the length of the sheet is changed, compensation will run automatically. No manual input value is required. We only need to change the length of the sheet. It is 600 mm in length now. Compensation is 0.06 mm. Enter 1200 mm. Compensation will automatically update to 0.13 mm. enter 2500 mm, compensation will automatically update to 0.27 mm. This is angle compensation. After the workpiece is processed, the actual angle may be inconsistent with the target angle. At this time, angle compensation is needed. Suppose the angle we want to bend is 90 degrees, but the folded workpiece was measured to be 92 degrees. Then please enter the angle of the actual folding sheet measurement. Note that clicking this input is Y1, Y2 selected at the same time, angle 92 degrees. After entering the compensation of 92 degrees, press Run. It will automatically become -2 degrees. 92 degrees minus 2 degrees will get the 90 degrees that we want. If we want to get 90 degrees, but after the workpiece is processed and measured, it is 88 degrees. So please enter the actual measured 88 degrees here. After running, it will automatically compensate for 2 degrees. 88 degrees plus 2 degrees is also 90 degrees. Another situation is that the bending angles at both ends of Y1 and Y2 are inconsistent. At this point, only one end needs to be compensated separately. Suppose we set 90 degrees after processing and measurement. Y1 is accurate 90 degrees, Y2 is 92 degrees. Then we only need to compensate Y2 separately. Y1 unchanged, press Start button. In this way, after compensating one end separately, the Y1 and Y2 angles will be consistent. This is the function of angle compensation.